This is the review for the electrolytic batteries. So well, let me just get my stuff here. So when we're talking about batteries, you're going to have two different things. So let me draw it here. You're going to have two containers here. One's going to be your anode, and one's going to be your cathode. And inside of these, you're going to have two metals connected by a wire to each of them. Okay. The important thing to remember is the what's it called? Mnemonic. Leo says GER, which stands for losing electrons is oxidized, gaining electrons is reduced. Okay, that's important. And then the other one is oil, right? No, sorry. What's the one for? Hold on, let me think. Anode. Oh, sorry. Here's the mnemonic for the battery. You have red cat, and anox. So obviously Leo GER is important for figuring out which one is oxidized and what's reduced, but this is important for the battery, red cat. So reduction occurs in the cathode. So this is reduced, reduction. And anox, so anode is oxidized. So anode oxidized. Okay, so that's important to remember. So what's happening when it's being oxidized? So we'll go down to Leo GER here. So we have oxidization. Oxidizing is when it's losing electrons. So we see that this anode is going to lose electrons, right? And then GER, gaining electrons reduced, the cathode is being reduced, so it's going to gain electrons. So that's how we figure out the flow of our electrons. It's always from anode to cathode. If you want to write that down, it's always from anode to cathode, right? Because the electrons are flowing away from the anode because it's being oxidized, and toward the cathode because it's being reduced. So what does that mean? It means that whatever this metal is, I don't have a particular metal picked out in mind, but whatever this metal is going to get smaller as the reaction occurs, and whatever this metal is going to get larger as the reaction occurs. So there's one main thing that I'm leaving out for this thing, something called a salt bridge. Okay, I'll draw my best interpretation of a salt bridge. So you have a metal here. So let's say it's, let's see, what's something that gets oxidized? You have I can't think of something offhand right now. But the whole idea is that since you have these electrons leaving here, right? And a lot of these metal particles now no longer have the electrons. Since they don't have the electrons, there's going to be a lot of positive things here, right? Remember, it's being oxidized. That means it's going to get more positive. Likewise, since this is being reduced, you're going to get a lot of negative charges over here. So in order to ensure that both of the containers are able to stay neutral, you'll have a salt bridge. And what the salt bridge is it's a container that links the two, the anode and the cathode, and it contains some sort of electrolyte, and by electrolyte, it's just salt. So it's something that'll dissociate. So we'll see that, let's say we have NaSO4. I think that's a salt. I'm not really sure at the moment if that is, but let's say I'm pretty sure that is. So we have the positive Na, so it's Na positive. It's going to dissociate into that, and SO4 negative. I'm pretty sure SO is just SO4, right? So then this negative charge is going to go over here, and the positive charge over here. So we'll see that Na plus ions will enter the cathode, right? Because there's a lot of negative charges over here. So in order to balance it out, the positive will match up with the negative. And since we have a lot of positives over here, the negative is going to go over to the anode in order to ensure that it is neutral. So that is, trying to think what else. So you can have something like a voltmeter here to read whatever the voltage is. And all that's going to read is that's going to read the amount of electrons that are being transferred along this wire in a certain time period. Remember, there's these mnemonics. If you don't like this one at the bottom, there's also oil rig, and that stands for oxidization is oxidization is loss. I don't like this one as much. Oxidization is losing, so you're losing electrons, and then reduction is gaining, so you're gaining electrons in reduction. And that's the same thing, Leo Ger, losing electrons, oxidization, gaining electrons, reduction, okay? So that is pretty much all the things that you need to know for the cell. And once you understand the cell, it's a lot easier to understand everything else that's going to happen. So I'll make a video quick just to go over some of the calculations that you'll need for tomorrow.